All right, friends, we are doing our review on Unit 5 Matter, and there are a couple questions that I told you to cross out. We are going to be crossing out 5 and 13. And anything on the test that has to do with that topic is going to be removed because that's not something that we are going to be studying. So no worries on that. That is actually compound is our... Can be broken into simpler substance is a compound. Okay. All right. Matter has a definite volume but not a definite shape is a liquid. Has a volume but it takes the shape of the container. A mixture that has the same composition throughout is called a solution. Solutions can be separated, but it is very difficult to do so. Changes in the identity of a matter is called a chemical change. You cannot change it back. It has completely changed its identity. Changes in which the form or shape of a substance, but the substance still is the same type of matter, is called a physical change. It can go back and forth, kind of like ice cubes melting or water going to ice. We can switch it back. All right, number 6. Joseph put water, sugar, and yeast into a balloon. Ooh, it's like our science experiment. Remember what we did with our science experiment. Then he put the balloon in a warm place for an hour. Which of the following is most likely to happen in Joseph's balloon? Okay, is most like the change that's happening in Joseph's balloon. All right, so these are different changes. Okay, so this is a physical change. This is a physical change. This is a physical change. And this is a chemical change. So the yeast, the sugar, and the water going together is a chemical change. We cannot switch it back. So that is what it is most alike. Number 7, Daniel put water, sugar, and yeast into a balloon. Then he measured the mass of the balloon. He put the balloon in a warm place for 2 hours. Then he measured the mass again. He repeated his experiment 3 times to get more data. Predict how the mass of the balloon changes. Now remember, the mass will always be the same. What changes is the width or the circumference around the balloon will change, but the amount of mass will not change. Whether it's a liquid or a gas and anything that is in there, matter does not change in mass, it just changes in form. So mass cannot be created nor destroyed, it just changes into something else. That is our law of conservation of mass. All right, which of these correctly describes change of state of water? All right, so if liquid water melts, does it turn to solid water? No, if liquid water melts, then if it is boiled, then it turns into gas. If liquid water boils, it turns into gas. So maybe solid water condenses, it turns to liquid water. Solid water has to melt to turn to liquid water. Water vapor evaporating to liquid water. Water vapor does not evaporate. Liquid evaporates. So this is actually backwards. So our answer is that. When an egg is cracked and put into a hot pan, it flows easily. After it cooks for a minute, the egg becomes solid. Why does the egg change? Well, the egg, anytime you're talking about cooking, we're talking about chemical changes. We can't change that egg back into a raw egg. It has changed chemical composition. So let's see, breaking the shell, physical change, no. Breaking the shell, it has nothing to do with breaking the shell. Heating the egg in the stove causes the egg to evaporate and become solid. Adding heat causes a chemical change in the particles to make it solid. If this was the case, we could change it back to a raw egg, but we cannot go back and forth in our solid state to a liquid state when we have chemical changes. All right, the volume of a given mass of gas in one of its physical properties that can change. Which graph shows how the volume of gas changes as the temperature increases? So our volume will go up as the temperature goes up. Think about when we put heat with our chemical change in our yeast and our sugar and our water. As the temperature went up, the volume went up. The mass did not change, but the volume of how big the balloon did. This graph would show that the volume goes down as the temperature goes up. This one would show that it remains constant, and this one would show that the volume would go down as the temperature goes down. But not at a consistent rate. So we want to show the consistent rate. Stacy tried to remove a metal lid from the glass jar, but the lid was too tight. Her mother held the jar so that the lid was in hot water for a minute, and then Stacy was able to turn the lid easily. How did the hot water make the lid easier to remove? Heating the glass jar made it expand so the lid turned easily. So expanding makes it bigger, so that means that it would make it tighter and it would make it harder. So that's not right. As a metal lid was heated, it expanded so it was not as tight. Water on the metal lid made it easier to hold so it was easier to turn. I don't think so. The water corroded the metal so it did not hold as tightly as to the glass. Well, corroding would take a long time. So the metal lid was heated, it expanded. So if you think about a lid, the lid is holding tight. Metal will expand if it gets a little warm, and then you can turn it a little bit. So that would be G. Which of these statements best describes the effective temperature on chemical changes? Chemical changes generally happen faster at higher temperatures. That is true. Chemical changes generally happen slower at higher temperatures. Chemical changes are not affected by a change in temperature. Chemical changes happen only if the temperature is very hot. Think about the balloons. The chemical change happened at warmer temperatures. At the colder temperatures, it almost didn't happen at all. That's why we put our food in a refrigerator. It slows down the chemical change, and the chemical breakdown of the food doesn't stop it, but it slows it down a lot. Claire is studying how quickly sugar dissolves in warm and cold water. First, she dissolves a 4-gram sample of raw sugar as shown in the following figure. So raw sugar has larger pieces. If you've never seen raw sugar, it looks like the large pieces of rock salt that we use in our other experiment. White sugar is very thin. It's like table salt. So take that in mind as I read this question. So she had 4 grams of raw sugar in both cold and warm water, and then she dissolves 4 grams of white sugar in both warm and cold water. So which were the following would the sugar dissolve the slowest? Now, in our experiment, we talked about what affects the change in what affects dissolving. We found that things that are smaller dissolve quicker, and warm temperatures help them dissolve more quickly. So we're going to say white sugar in the warm water will dissolve it more quickly. It will dissolve. It will just take longer because we have more surface area here. And cold, it doesn't dissolve very well or as quickly. Mrs. Lopez is a chemist who is studying salt crystals. She wants to slow the rate at which a crystal dissolves in a solution of water. What could she do? She could cool the solution. Stirring will make it faster. Heating will make it faster. And making it smaller will make it faster. This will slow it down. Okay. Nadia has a mixture of oil and water. She wants to separate the mixture. How can she do this? By using a magnet to attract the oil? Well, oil is not magnetic. By pouring the mixture through a sieve, by evaporating the water from the mixture, or by letting the oil float to the top and skimming it off. Well, if you evaporate water and oil will both evaporate, so that won't work. Pouring a mixture through a sieve is so you can find a solid in a liquid. So that is what I would do, is I would let it float to the top, because water and oil do not mix. So if you let them sit, they will sit on top of each other and you'll be able to separate them more easily. 17. A container holds a mixture of glass shards and iron fillings. What is the best way to separate the glass shards from the iron fillings? Well, you can use a magnet. Okay, that will take everything out of the glass because magnets attract iron. This diagram shows what happens when water changes state. Okay, so which statement correctly explains some of the changes? Okay, so gas to a liquid would be condensation. I'm just filling in. So if you see this diagram, fill this in. A liquid to a solid would be freezing. A solid to a liquid would be melting. a liquid to a gas is called sublimation. But we haven't studied that, but I'm filling that in. So these are the temperature increases in steps 1 and 2. So let's see. If I have a gas to a liquid, yes, it is increasing. If I have a liquid to a solid with freezing, it is decreasing. And then it is decreasing. Temperature is decreasing. It's going down. It's colder. So that's not right. Energy of the water particles decrease in steps 1 and 2. Yes. Energy of the water particles decrease in steps 3 and 4. Well, if we are melting, we are increasing, not decreasing. Motion of the water particles decrease in steps 3 let me see. They would be increased. So our answer would be here. The water particles decrease because we are taking away energy because it is becoming colder. When gas goes to a liquid through condensation, it's because of cold. If liquid freezes into a solid, that means it is because it is cold. And the water particles lose energy because there's less thermal energy.